Hello folks, how are you all doing? I hope you're well and looking after yourselves and your families. I want to set you off on a new Nat5 Physics topic. It's part of the dynamics section and it is to do with scalars and vectors. I've created a document that contains all of the information that you're going to need, links to different websites, etc. And I've also included the learning intentions that are specified by the SQA so that you know what it is that you'll be expected to know about. Now then, to set the ball rolling, I thought it'd be good to put vectors into context. Why do we have vectors and what are they used for? Well, vectors and scalars are types of measurements that are used throughout science and technology. Scalars have magnitude or size only. An example would be speed, how fast a thing is moving, whereas vectors have both magnitude and direction. For example, velocity, which is how fast a thing is moving in a certain direction. And this is important because we need to be able to understand and predict motion and forces in more than one direction. Now, there are so many different fields of science and technology in which vectors are key, it would be impossible to list. But two examples could be GPS, Global Positioning System, and wind turbines. Your phone knows where you are by using GPS. Many of the apps use that information to help you to get where you need to go to or to find things that are of interest to you. And GPS is also of vast importance to industry and the rescue services. And it works by using the exact known position of at least 4 satellites, the speed of electromagnetic waves, and the time taken for signals from the satellites to reach your phone. And these are the components of the equation: speed equals distance divided by time, and the vector equivalent, velocity equals displacement by time. With this information, your exact position on the planet can be calculated. And that's fantastic. Brilliant, really useful. And then there's the design of wind turbines and the choice of suitable locations for them. And that uses fluid dynamics, which is a complex branch of physics that you maybe only need to study if you go to university. But it's based on the changing speeds and directions and forces that are in air. And these changing quantities are all vectors. Now then, I have found a lovely little radio podcast about 15 minutes long which discusses just how important GPS is to the modern world. And I've also found you a nice little video to watch about how wind turbines work too. So, if you get the document, which has got all of the instructions on, I'd like you to work through that. So there's the radio podcast to listen to, there's the video to watch. I'd also like you to go to Scholar and work through the Nat5 Dynamics, Vectors and Scalars section. And then when you've done that, you can go on to the BBC Bite Size and work through their Nat5 Vectors and Scalars section. And by the end of that, you should be able to know all of the kind of stuff that the SQA would like you to know about. Brilliant. So, off you go. Oh, just a minute. I think I'll sing you a song. I don't know any songs about fluid dynamics, but I do know a song about using phones to help find somebody. So that's maybe a bit like GPS. Right. Let's see. It goes a bit like this. I put a nickel in the telephone, dialed my baby's number, got a busy line. Each time I called, I got a busy tone. At my baby's number, just a busy line. I called her uncle in Jamaica, left a message with the baker, even checked her number in the telephone book. I got so awfully worried. To my baby's house I hurried. When I got there, found the phone was off the hook. Just then I walked up to my baby and I got my baby's number. She was sitting in the parlour doing fine, busy kissing someone else while I was keeping busy with a busy line. Oh, I do know a song about wind turbines, but I'll save that for another time. Okay then, off you go, get the documents, follow the instructions, and have yourself a good time learning. And I'll catch you soon.